In this lesson, we're going to talk about the measures of central tendency. We have three ways to describe distributions. Shape, which we talked about in Chapter 2, and we'll talk a little bit more about that in just a minute. We have center, which tells us the middle of the distribution. Okay, and then we have spread. Is it really close? Are all the data really close together, or are they pretty spread out? All right, so remember the distribution shapes that we talked about previously. We have the uniform, where every data value had the same frequency. We have bell-shaped, where it starts off low, rises to a peak, and then comes back down. It's pretty symmetric. We have skewed to the right, where the highest peak, is to the left, and there's a tail off to the right. And then we have skewed to the left, where there's a tail on the left-hand side, and the peak is towards the right-hand side. So we're going to look at three ways to describe distributions using the center, and that's what we're thinking about as the middle. Okay, so first we have the mean, which typically a lot of people think of as the average, and it's kind of like the center of gravity. Okay, if you were to take all of the data pieces, put them together, and then divide by however many data pieces there are, that would give you the mean. Then we have a median, which is the middle number, and a good way to remember this is if you're driving down the road, where is the median? It's in the middle of the road. So the median is that middle number. And then mode is the most frequent. It sounds like most frequent or most often. So that's the one that you have the most of. All right, so let's take a look at the arithmetic mean. Okay, and this is the first one that we just talked about. We take the sum of all the values, like I said, add them all up, and then divide by however many there are. And so you can see the expression there of the x sub 1 plus x sub 2 all the way up to x sub n, and then divide that by n. And then in the last part, that funny looking e thing is called a sigma. It's a Greek letter, and that basically just means sum of, and then x sub I means you're taking all of the x values and adding them up, and then divide by n, which is how many there were. So the population mean is called mu. That's a Greek letter, kind of looks like an M, but it's called mu, and it is a parameter because it is the mean of the population. So it's describing the population. And then we have a sample arithmetic mean, called the sample, we call it the sample mean. It's called x bar. And you can see that it's noted with an x with a bar at the top. And it is a statistic, So we also have a sample mean, which is called x bar, and it's a statistic because it's describing the sample. Now let's take a look at the median. Okay, in order to find the median, which we denote with a capital M, first we arrange the data in ascending order, so from least to greatest, and then we determine how many data pieces are there, how many observations are there, that's your N, and then you're going to find the middle of the data set. So if there's an odd number of data values, then you're going to take the one that's exactly in the middle. If there's an even number, then you're going to have to take the middle two and find the mean of those. So you're going to add them up and divide by 2. So let's take a look at an example. All right, so we're going to find the mean and the median of this data set. Suppose these are some test scores. And so we want to find the mean test score. And so we're going to add up all the values. And then we divide by 15 because there were 15 of them, and we find that it's 81.3. Then we want to find the median. So we line up all of the values, we write them down in ascending order, and there are 15 values, so we can find the one that's in the middle, and that's going to be the value number 8. Okay, so there will be 7 to the right and 7 to the left of that data value. So 82 is the median here of this set of data. Now you can see that the mean and the median are not the same. So depending on your data, sometimes you might want to use the mean as a descriptor of your data. Sometimes you might want to use the median depending on what kind of data you have. And we'll talk about outliers later on. But that might be a reason why you might want to use one over the other. All right, so what would happen if we only had 14 data values? Let's suppose we did not have the 100%. Okay, so now we only have 14 data values. So now to find the median is a little bit different. We have to find the middle two values. So we have 77 and 82 are the two values in the middle. You can see that there are 6 to the left and 6 to the right. And then we're going to add them and divide by 2, and so we get 79.5. So that's how you would find the median if you have an even number of data values. All right, so let's take a look at an example of the term resistant, okay? The following data represent the travel time in minutes to work for all 7 employees of a startup web development company. Okay, so we have different values of time, travel times in minutes. Suppose a new employee is hired who has a 130-minute commute. How does this impact the value of the mean and median? So resistant means that your measure of central tendency is not going to change a lot given an outlier, okay? And so the mean before the new hire was 24.9. If you added up all of those 7 travel times and divided by 7. The median, if you put them in order, is 23 minutes. So notice they're not too different. And you can see this dot plot here that shows you the spread of, or the distribution of the data, okay? And so now let's take a look and see what happens when we have that 130-minute travel time. So now you can see that the mean is 38 minutes. That changed drastically. The median did not change drastically. Yes, it went up a little bit, but a minute and a half is not that different when you look at this data. So the mean is not resistant to outliers, a really, really big number or a really, really small number in comparison to the rest of the data. The median is resistant because you're taking that middle number. If you have one that's really far to the left or really far to the right, it's not going to change the median that much. Now let's take a look at the relationship between mean, median, and distribution shape. So if you have a graph that's skewed to the left, if you have a set of data that's skewed to the left, then your mean is going to be substantially smaller than your median, okay? Your median is going to have a higher number of frequencies. If you have a symmetric distribution, then your mean and median are roughly the same. And if you're skewed to the right, if your distribution is skewed to the right, then your mean is going to be substantially larger than your median. All right, let's take a look at an example of mode. Okay, so the following data represent the travel time in minutes to work for all 7 employees of a startup web development company. So we've got these values, and we want to find out what is the mode. Well, which number occurs the most frequent or most often? 23. So that was pretty easy. There was no arithmetic involved in that one. All right, so if you have a distribution that has one mode, you see that there is one peak. And then if you have a bimodal distribution, which we're not really going to get into in this class, but if you have a bimodal, then you have 2 modes, so you have 2 peaks.